Okay, let's look at these here. So the 5 properties of a parallelogram. What can I say for the first one here? Opposite blank are blank. Sides are congruent. Okay. So I could do some tick marks like that to show that. All right, what's another one? Rachel. Opposite angles are congruent. All right, so marking angles. Number 3. Here. Opposite sides are parallel. This is the one that gives it the name, parallelogram. So parallel, we use arrows. Number 4. Consecutive angles are supplementary. This one is kind of hard to draw without numbers. So I just like to put arrows and say add to 180. That's we could put numbers in there too. And we can do it for all of them if we want. Or you can just put it for a couple of them. That one's the hardest to draw. And then number 5. Here. Diagonals bisect each other. Okay, so I've already used the 1 and 2 tick marks, so I need to use 3 and 4 this time. Okay. Turn to the back of this packet real quick where it's an empty page. Is it empty? No, it's not. Oh, no. Oh, wait. Turn 2 pages into the middle. There's the blank page here. There we go. There's a blank page somewhere on the back. Yes. Okay. So on that paper, we're going to draw something very similar to what we drew last time. You can make the whole paper this category if you want. The whole paper is going to be polygons. So we want to remember for polygons, the formula 180 times n minus 2 for the total. So we can say the interior angles 180 times n minus 2. That's one of our important formulas. What are the exterior angles equal? 360 always. I have a feeling I'm going to have to go down. Okay, so then we talked about what's called a subcategory, category inside. That's pretty big. That includes parallelograms. Remember what that was? Quadrilaterals, yes. I'm going to make my quadrilateral square just a little bit bigger here. My quadrilateral, a little bit bigger. What would be out here? What are some examples of things that would be outside the quadrilaterals box, but inside the polygons box? What's that? Triangles. Triangles would be out here. I thought I heard one at first. Octagons, yes. Octagons. So those would be outside. Stars, okay, yeah. Stars have a decagon.
What's polygon?
All the gons, yeah. Any n-gon, yes. N-gons except four-gons, yeah. Yes. So all polygons that aren't quadrilaterals would be there. What are some things that would be outside the big polygon box? Open shapes, yes. This one, if you don't have room on your paper for it, that's fine. But make sure it's outside of polygons. Yeah, open shapes, like something like this. Yep. Maybe like circles. Circles would be out here. Spheres. All kinds of stuff. Elephants would be out here. You guys would be out here. This geometry class would be out here. What's an elephant? It's a mammal. It's a large mammal.
No.
Native to Africa and India.
I thought I know that. I'm like, is this a shape? Is there a shape called elephant?
No. I was just thinking of like a literal elephant. Yeah. Yeah. Food.
With 3D shapes?
Yeah. Yes. And so polygons are many-sided 2D shapes. Polyhedrons are many-sided 3D.
Are you ever going to talk about shapes?
No. No, probably not. Well, actually, yeah, we'll talk about volume and surface area. So we'll talk about cubes and rectangular prisms. We don't get too into detail. But like if you ever play a game with like some fancy dice, like a regular, exactly, the D&D dice, like your D20 is like an icosahedron, a tetrahedron is four-sided die, decahedron, dodecahedron, octahedron. That's the good stuff. Anyways, that's off topic, kind of. So, okay, inside quadrilaterals, we talked about a big category called parallelograms. And we just listed all the properties, so we don't need to do it again. They've got those 5 properties we just listed. And so inside of parallelograms is what we're going to focus on today. What 3 things are we going to talk about? Rectangles, rhombuses, and squares. So all 3 of those are special types of parallelograms, which means they're going to have all of the same properties of a parallelogram, plus new things that make them special.
So what's like a quadrilateral that's not a parallelogram?
Great question. Can anyone think of an example of a quadrilateral that's not a parallelogram? Trapezoids. So that's one of the ones we'll talk about in next class. And there was one other special type. Heights. But then also, there's just non-special quadrilaterals. Just something with 4 sides. It's like, it kind of looks like a trapezoid maybe, or it could be something like this. It could be concave. That sort of looks like a triangle. I didn't draw it great, but yeah, just like kind of boring quadrilaterals. They're not boring. They're just, I don't know, not as interesting. Kind of looks like a trapezoid, but it's not. There we go. There's kind of a fun quadrilateral. Those don't really have any special properties. There you go. Now that's definitely not attractive. So I'm doing this just to help sort all these things. All right, once you're done writing, we can go back to the first one. Okay. So at the top there, what's true about all quadrilaterals? 4 sides. Yes. What are the angles add to? .360. So the angles always add to 360 for a quadrilateral. Okay. So a rectangle is a special type of parallelogram, which means opposite sides are parallel, opposite sides are congruent. So you can abbreviate them like this if you want. Opposite angles are congruent. Consecutive angles are supplementary. Diagonals bisect each other.
In a rectangle, are like opposite angles are, or consecutive angles are supplementary and congruent, right?
Yes, which means they have to be 90 degrees. Yeah. So yeah, what we're going to add that's special to a rectangle is that there are 4 right angles. And so, you know, you're combining them, which is true. Remember that this property comes from it being a parallelogram. But yes, consecutive angles would be congruent. So we have 4 right angles in a rectangle. And then the other property that is special to a rectangle has to do with the diagonals. And it says that the diagonals are congruent. They are congruent. So the way that I'm going to mark that on this picture here is by putting 1 tick mark on each of the halves, because they still do bisect each other. It just means that all 4 pieces of those diagonals are the same. If we want, we can draw in the parallelogram properties as well. It's going to make the drawing a little bit cluttered, so, well, not that cluttered, I guess. But you could draw those in as well if you want. If you have different colors, it could be helpful too. Okay, so next we're going to talk about a rhombus. So remember from our picture here, a rectangle and rhombus are separate unless they overlap. And then whenever they overlap, what is that called? A square. So first, we're talking about specifically just rectangles, and now we're talking about just rhombuses. A square is going to have a combination of both. So a rhombus is a parallelogram, which means opposite sides are parallel, opposite sides congruent, opposite angles congruent, consecutive angles supplementary, diagonals bisect each other. Does anyone know what makes a rhombus special? This rhombus kind of looks like a square too, which I don't love. Thought I had. This one here would also be a rhombus, like a diamond. This is also a rhombus. Anyone know what makes a rhombus special? A rhombus has 4 congruent sides. So we could say all sides are congruent. We've got one about the diagonals. What do we think? Are the diagonals congruent? Are they the same length? No, like I can see, especially in the diamond, like this one is really short, this one is really long. Any guesses what is true about the diagonals? What does it look like they're forming in the middle there? They meet at a right angle, yes. So the diagonals are perpendicular. And then something else that is special in a rhombus about the diagonals is that they bisect the opposite angles. So where they meet here, they are cutting those angles in half. So see, I'm putting the same tick marks on like both parts of the angle. Notice this also shows that opposite angles are congruent. If I'm using the same set of tick marks for the top and bottom and the 2 sides. And then also, if you want, we can put in the parallelogram properties on here. If you have different color, that could work. Let's see, I only really need to do diagonals bisect each other. Okay, so what's going to be next? What's the last one? Oh, well. There it is. Squares. Okay, so a square is both a rectangle and a rhombus. A square is also what? A parallelogram, yes. So a square is going to have all the properties of a parallelogram. Opposite sides parallel, opposite sides congruent, opposite angles congruent, consecutive angles supplementary, diagonals bisect each other. It's going to have the properties of a rectangle, so 4 right angles. Diagonals are congruent. It's going to have all the properties of a rhombus. 4 sides congruent. Diagonals are perpendicular. Diagonals bisect opposite angles. So basically drawing in all those other properties, 4 congruent sides, that's going to fill out the square completely. The square's got a lot going on. Oops. Oops. I use blue. I'm losing track of my colors here. If we were bisecting a 90-degree angle, what size will the 2 angles be as a result? If we bisect 90. 45, yes. So each of these little ones here would be 45 degrees. Notice we are forming a lot of 45, 45, 90 triangles here. How many 45, 45, 90 triangles do you see? Let's see more. How many? 8. There's 8. There's these 1, 2, 3, 4 right here. And then there's also this one, and then there's also this one, and this one. I guess if anyone's colorblind, that's not gonna be hard to see. There's also this one, this one. 8 45, 45, 90 triangles in the square. It's a lot. That's almost 9 45, 45, 90 triangles, if you think about it. When a shape like a square has 4 congruent sides and 4 congruent angles, so all the sides congruent, all the angles congruent, what is our word for that? All the sides and angles the same. What is it? All sides and angles the same? You got a word for that. It starts with an R. It's in the warm-up. Regular, yes. So a square is regular. It is both equilateral and equiangular. Okay, with your partner, I want you to do this next section here. Based on the information that's given, is this shape a rectangle, rhombus, square, or is it just a parallelogram? We'll talk about that. You want to choose the best answer, the most specific answer. So we want to choose the most specific answer that we can. So the least specific would be what? What's got the least amount of detail in it? Parallelogram. And then I would say rectangle and rhombus are tied. And what's the one with the most detail? Square. Okay. So our first thought, like for number 1 here, is that definitely a parallelogram? Yes. Okay. Do we have enough information to say it's a rectangle or a rhombus? No. Okay. For a rectangle, what would we look for? 90-degree angles. Okay. We have no 90-degree angles. If this was a rhombus, what would we want to see? All congruent sides. So this one's definitely not a rhombus. We don't have enough information to say it's a rectangle. We can only say it's a parallelogram. Okay. Sometimes the answer seems to jump out at you. Number 2, what is that? That's a square, right? We see 4 congruent sides, we see 4 right angles. We don't really need to think through a lot of options for that one. Yeah. Okay. Number 3, what do we think that is? A rhombus. Okay. Why? 4 congruent sides. Okay. Could that be a square? Could it be a square? It could be. Do we have enough information to say for sure it's a square? No, we would need to see some right angles in there. So we can't say it's a square. Definitely say it's a rhombus. Number 4. Rectangle. Could this one be a square? No, why not?
Because not all the sides.
Exactly. Okay, but we're seeing the right angles in there, so we know it's something special. Number 5.
I did right.
Rectangle. Do we agree? Could this one be a square?
I mean, it could.
It could. Yeah, it would not be drawn to scale, but we don't know it's a square for sure. Definitely a rectangle. And number 6. Rhombus. Could this one be a square? No, why not? 91 degrees, yeah. Okay, questions on that? All right, we're gonna do some examples here. HIJK is a rectangle. Find the value of x and the length of each diagonal. Draw a picture. Okay, I want you guys to check my work here. Did I draw it correctly? Tate, you're shaking your head. Why? What's that? Okay. Yeah. Okay. Order when I do what? Okay. So, which ones could I switch? J and K. Yes. Okay. Nice. Okay. So, just a reminder: the starting point doesn't matter. Like this is also correct because it goes HIJK around like that. The order that I go around doesn't matter. I could go HIJK. But what's the key is exactly what Mia said. They have to go in order as we do the letters there. And it makes a big difference. It makes this problem, it's the difference between being able to solve this problem and not being able to. So if HJ is 3x plus 7, and IK is 6x minus 11. These are the diagonals of a rectangle. What do we know about the diagonals of a rectangle? Jess?
They're equal.
They are equal. Okay, that's not true in a parallelogram or in a rhombus, but it is true in a rectangle. So this is the difference between being able to solve this or not. So we would just do 6x minus 11 equals 3x plus 7. We're going to get the x's to one side, numbers to the other. We get x equals 6. Is that the end of the problem? No. What does it say to do?
To solve for HJ.
Yes. So I'm just going to plug that back in. Do I have to plug it back into both, or could one be enough?
Just one.
Yeah. We just have to do one because they should be equal.
Oh, I did.
But we could always check both just to make sure. Yeah, we're going to substitute. Okay. You guys do the second one, and then we'll check it in about a minute. All right, so we draw the picture here. We label the diagonals, and what do we want to do with those two expressions? Set them equal, add 180, do something else. Come on, guys. Yeah, they're equal. The diagonals of a rectangle are congruent, so we set them equal. It's like x equals -3. That what you guys got? Yeah. If I plug that back in, -9 plus 22 is 13, right? Yep. And those diagonals. Should be the same one. Question on that? All right. Let's go to the next page here. All right. I want you guys to try these. So what you're going to do is you're going to use the properties to try and set up an equation. I'll give you a hint. A lot of things are going to be set equal to each other.